Hello everyone, welcome back to the another session in design and analysis of algorithms. This video is continuation part of optimal storage on tapes. So this video will help you out to understand this problem, optimal storage on tapes problem example, through some example. And in this example we will be going to take some number of programs and we'll arrange the number of programs. That means we'll store these programs on the tape, single tape, and we'll take some multiple tapes also to store the number of programs, and we'll calculate retrieval time of single tape, retrieval time of multiple tapes, okay, and also we'll calculate the complexity. So this is what the things what we are going to discuss in this video. Now let's start with the first slide. So this is the algorithm what we were already discussed in the previous video. So here n is number of programs, n is number of programs, m is what? Number of tapes. That means it is purely discussing about multi-tapes. So before we discussed about multi-tapes to append the program, let's talk about single tape. Then we'll come to that example, okay? Now, so assume that n is equal to 3, L1, L2, L3, that is 5, 10, 3. This is what my original problem. I am just taking some tape to store this job. That is the task. I have the task of L1, L2 and L3. The task is what? I1, I2, I3. I1 will get completed in 5 and I2 is 10. The length I am talking. I1 length is 5, I2 length is 10, I3 length is 3. So these are what the original length of each job. Now, in which order I have to place this where I'll get a minimum retrieval time. So for this, what we'll do is, without greedy method, we will be going to solve this problem to show you the complexity, okay? Now, without greedy method, what we'll do is, we'll see all the permutations which are required to store these jobs on the tape. That means the first combination, the first permutation is what? 1, 2, 3. When I wanted to place 1, 2, 3 on this tape, now what is the retrieval time? The retrieval time is what? I can access 1 directly. So the length of 1 is what? 5. And before I access, if I wanted to access this 2, so I cannot go to 2 directly. I have to go to 2 once after I finish 1. So I have to take 1 job length and 2 job length. The same. If I wanted to access the third task from the tape or retrieving the third task from the tape is required to finish 5, 10 and 3. That means first job length, second task length and third task length. 5 plus 10 plus 3. So the total is what? 5 plus 15 plus 18. That means 38. This is what the retrieval time to access in this in this order, 1, 2, 3 order, the first job, second job, third job. And the second permutation is what? I can also store the task on the tape in the order 1, 3, 2. If it is 1, 3, 2, then what is the retrieval time? If I wanted to retrieve 1 from the tape, then that the time is what? 5. And for 3 the time is what? 5 plus 3. And for 2 the time is what? 5 plus 3 plus 10. So the total the time is what? 31. So 31 is the retrieval time of 132. And we'll see the other permutation which is 231. So for this 231, the retrieval time is what? 10 plus 3 plus 10 plus 3 plus 5. So the total is 41. And the next is what? 213. And the next is 312. And the next is 321. So in 213, If you calculate the retrieval time, you will get 43 as your retrieval time. And for 312, if you do the same way of calculating the retrieval time, you will get, which is very minimum, that is 29. And if it is 3 to 1, then it is 3 plus 3 plus 10 plus 3 plus 10 plus 5. Now it is 34. So among all this, what is the minimum retrieval time? 38, 31, 41, 43, 29, 34. 29 is the minimum retrieval time. So as it is a minimization problem, optimal storage on tapes is a minimization problem. So I can apply greedy method. So I'll apply greedy method here. So before applying greedy method, I have to make my list in sorted manner. Sorted manner, that means non-decreasing order or otherwise increasing order. When you make this length of the job or length of the task in non-decreasing order, then how it looks like, among these three, which is having the if you make this 3 in increasing order, then which will comes first? 3 will comes first. Next 5 will comes first. Second. Next is 10. That means corresponding jobs are what? 3 length of I3. Okay. 5 is what? I1. 10 is what? I2. That means it is what? 3, 1, 2 is the place of order. So this is what the perfect permutation where you can keep on the tape. So if you place 3, 1, 2 order, what is the retrieval time? So retrieval time of 3, 1, 2 is what? Sum of 1 less than or equal to I less than or equal to n, which is I length of I, correct? So that means I have to calculate the length of third job is what? Third job length is 3. And the first job length is what? 3 plus 5. The next job length is what? 3 plus 5 plus 10. So put together 3 plus 8 plus 18, what it is? 29. 29 is what? The very minimum figure what you got from the previous example. That's what greedy method will reduce the time complexity from n factorial to n log n. N factorial means what? In the previous example, we were taken n value as 3, right? So n value is 3. 3 factorial, which is 3 into 2 into 1, which is 6. You got 6 combinations out of feasible solutions, which is 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1. So all these are what? 6 combinations. So if you apply greedy method, the time complexity will reduce from n factorial to n log n. So this is what greedy method, which will give you the solution for the optimal storage on tapes problem. So here we were used only single tape. It is only single tape. We will solve the problem that the tape is going to have 3, 1, 2 order. The order of jobs what I going to finish is third task will get finished first, then first job, then the second. So this is the order of placing the task on the tape, and retrieving is what? The same 3, 1, 2 will get the 29 as our retrieval time. So this is what single tape. Now we'll see the multiple tape, and this question is previous question paper, OU previous question paper question. Now let's solve this example using greedy method. So I told you greedy method can be applied once after you make the elements in non-decreasing order or else increasing order or else sorted manner. Now it is your job to make the list into sorted manner. So my primary job is what? Placing the items in non-decreasing, that is 3, 4, 5, 6, 7, 8, 10, 11, 12, 15, 18, 26, 32. Very simple. This list is what? From this list only I made it sorted fashion, non-decreasing order. Now once after you did this one, in the algorithm what we were learned, when you have j is equal to 0, that means initially you don't have any append programs to be added onto the tape. So you are given with multiple tapes, which is 3. That means T0, T1, T2. These are what your tapes. Now you have to place the task on the tape. So which job will get placed on which tape is going to be get calculated using the algorithm. So in the algorithm we were seeing this, right? J is equal to J plus 1 mod M. M is what? The which tape you are going to take this, right? So now your J is what? J is what? Initially it is 0. Now first of all you have to append I is equal to 1. That means I is equal to 1 is what? 3. So 3 I am going to append on first tape. Okay. And so to allocate this tape, to allocate this job, I am just making this as my next append program, that is J plus 1. So J plus 1 is what? 0 plus 1, that is J is equal to 1. So in which tape I am going to place this one? On T1 tape. So that means 4 is here. Now the next job is what? J plus 2. So J plus 2 mod M. M value is what? 3. So now next task is going to be stored on T2 tape. 3, 4, 5. And the next is what? 6, 7, 8. Next is 10, 11, 12. Next 15, 18, 26. And the next is 32. There is no constraint that each tape should have the same number of tasks. No, there is no constraint. According to the algorithm of this, we will place all the tasks, all the number of programs into tape. So once after you place this one, you have to calculate retrieval time. So now you have to calculate retrieval time of T0, T1 and T2. So what is the retrieval time of T0? T0 is equal to 3 plus 6 plus 3 plus 6 plus 10 and 3 plus 6 plus 10 plus 15. So in the examination point of view, you have to place here number. That means it is I3 tape, it is I6 tape, I10 tape, I15 tape. Okay, I'm sorry. So that means you have to make this I suffix also. So I'll just change this for the better understanding. So I3 is what? I1. 4 is what? I2. I'm just giving the indexes to avoid all type of confusions from your mind. I'm just giving indexes. Okay. Now these are. The more you will change this index values, the more confusion you will be having in your brain. So either you can make this order of items or else you can make this order of items. Anything is okay. It all depends upon your way of understanding. You can make this items or I1, I2, I3. So once after you sorted these items into non-decreasing order, then also you can make an index. But point to be very clear that which tape is going to have which item, that you have to be very clear. So T0 tape is going to have what? T0 tape is going to store. I mean, it had what? I1 is with T0 and 6 is what? I4. I4, that means fourth task is also completed from T0 and this is what? 10. 10 is what? I7. I7 and 15. 15 is what? I10. 32. 32 is what? I13. So T0 having the task which is 1, 4, 7, 10, 13. These are not length of the task. These are what? Name of the task. That's what I'm clearly telling you to understand this. So these are what indicated with I. When I wrote only a numerical part, then you have to understand it is the length. When I have given with I, you have to understand that is indicating the index. Fine? Right. Now calculate T0. T0 is what? The value. So you'll get T0 is 131 if you sum all these things. Now again T1. T1 also you can calculate. So now T1 is what? So I'm calculating T1. T1 is equal to which items we were having? Length of 4 and length of 7, length of 11, length of 18. You can identify the number of index respective according to this length of the program. Okay. Now the retrieval time of T1 is what? 4 plus 7 plus 4 plus 7 plus 11 plus 4 plus 7 plus 11 plus 18. So finally, you will get the answer which is 77. So now T2. T2 is what? If you do the same way, T2 items are what? T2 length is what? It is executing the tape. We are going to retrieve the tapes which are having the length 5, 8, 12 and 26. So if you calculate the retrieval time of it, that is 5 plus 8 plus 5 plus 5 plus 5 plus 8. 5 plus 8 plus 12 plus 5 plus 8 plus 12 plus 26. So the answer is what? 94. Finally, you got individual tape retrieval time. T0 is 131, I guess, in the previous slide. So T0 value, T1 value, T2 value you got. So now what you have to do is, you have to apply in the formula, that is what? Your mean retrieval time. You have to calculate mean retrieval time. So d of ti is equal to I is equal to 1 to n li. This is we were calculated for each tape. That means T0 value 131, T1 value I guess it is 77, T2 value it is 94. So individually we calculated with this formula. Now you have to calculate mean. So that means mean retrieval time, MTR is equal to d of t by n. What is d of t? Sum of d of t. What is it? 131 plus 77 plus 94 by 3. So around you will get 100. So 100.6. So this is what the mean retrieval time using multi-tapes to solve this problem. So this is what multi-tape solution. You have to calculate MTR value, mean retrieval time. Thank you all.